Hello viewers, you're welcome back to class. This time around, we're going to start a new topic, indices. The topic is indices, and we're going to start with some laws of indices. In this video, I'll expose us to 4 laws of indices and some examples in the neighborhood of the laws. Indices is a plural of the word index. So in simplifying some expression that involve pairs, or we can call it exponents, there are some rules or laws that guide all simplifying those expressions. So the plural of index can be called indices, pairs, or exponents. So there are some expressions that they have pairs, they have exponents, they are with index. So in solving them, we have some laws guiding the solving. So the first one I'll be speaking about here is the multiplication law, which implies that when you have the same base and the operation between the numbers or letter that are the same, if the operation is multiplication, the pairs will be added. That's the multiplication law. And the next one I'll be talking about is the division law. When you have the same base, it might be a number, it might be a letter. If you have the same base, the pairs will be subtracted in solving. Like here now, we have x raised to power a divided by x raised to power b. So in solving now, since the operation between the letter x is division, we're going to subtract the power. It will be a minus b. In the case of multiplication, the pairs will be added. So we move to the third one, which is the pair 0. In other words, if we have any number raised to the power of 0, the value for that particular number or letter or figure is 1. So that's the third law I'll be teaching this video. And the fourth one, so the fourth law I'll be speaking about in this video is the negative pairs. Negative pairs or negative indices or negative exponents. In this case, if we have a particular number or a figure and is raised to the power of a negative number, that is, the power is negative, so we call it the negative powers law, and it can be written as 1 divided by x raised to power a, which gives us s raised to power minus a. By the time we begin to deal with illustration example that are numerical, we get the usage of the law very well. So I move to some examples I have here. Examples. Simplify the following expressions. Simplify the following expressions. The first of it is 4x multiplied by 5x raised to power 5. 4x multiplied by 5x raised to power 5. From here we can see that the letter x is the same thing as the letter x. So, since we have multiplication as the operation here, we're going to multiply 4 by 5, which gives us 20. Multiply 4 by 5, which gives a 20. 4 by 5 gives 20. And this s, letter s, is common to both. So we're going to pick one. S raised to power 1 is the same thing as x. So this is 1 plus 5. Since this s as base is an equal base, so we're going to add the powers because the operation in between the expression is multiplication. So we have 20x 1 plus 5, which gives 20x 1 plus 5 gives 6. That's all about the letter A of the example. We move to the letter B of it, which is 18x raised to power 5 divided by 9x raised to power 4. Viewers, the operation we have here is a division, and there is a law of indices for division law, in which the powers will be subtracted. So for 18 now divided by 9, we're going to have 2 for 18 divided by 9, and this is a common base, x. So we have x raised to power 5 minus 4, which gives 2x. 5 minus 4 gives 1. 2x raised to power 1, which is the same thing as 2x, which is the same thing as 2x. So the third one, the letter C of the example, is 10 raised to power 3 divided by 10 raised to power 0. Viewers, if you look at this particular question, the division law will be used, and also the zero power law will be used. So I want to do it in 2 ways. First, since the base are equal, I pick one. Now, since again the operation between the numbers is division, so I'm going to subtract the exponent. So I'll have 3 minus 0, which give 10 raised to power 3, because 3 minus 0 is 3. That's good. Another way of doing this is, and it's simpler, like shorter than this. 10 raised to power 3 divided by 10 raised to power 0. If I try to explore the 0 power law, it shows that this 10 raised to power 0 is 1, because any value, any letter raised to power 0 is 1. So 10 raised to power 3 divided by 1, and it gives 10 raised to power 3. Good job. Now the fourth one, which is the letter D example, is 1 divided by 9 all raised to power minus 1. And this is the one in which we're going to use the negative powers law, because the power here now is a negative number. So I want us to do it this way. 1 over 9 minus 1. According to the law, if we have it this way, it means that there is a 1 up for the actual value, which implies that this minus 1 power is going to introduce a 1 divided by 1 over 9 to this actual value. The actual value is 1 over 9, but this negative power will introduce 1 divided by 1 over 9. We introduce a 1 division on the actual value. And going by this, 1 divided by 1 over 9 is going to give us 1. Division will change to multiplication, and denominator will come to the numerator position, and numerator 2 will come to the denominator position. So we're going to have 9 divided by 1, which is 1 multiplied by 9 is 9, and 1 by 1 is 1. In other words, we have this, and the answer now is 9. Viewers, we still continue in these laws of indices at subtopic, and the broad topic is indices. Laws of indices is what we are exploring now. I've been able to give us 4 laws of indices and examples, 4 examples in relation to the 4 laws. So by the grace of God, in the next video, we'll be treating more laws of indices and more examples. Thanks for watching, viewers. Do like, share, and subscribe to my YouTube channel. Bye for now.